Okay, Rachel, so this is the last one in part 2. This is 7.38 that I've got here. And so again, they've given us this chart, and we've got the information, especially this information here, to help us out. So we have our slope, or our B1, which is the bottom number, and our intercept, or our B0, which is the top number. So it says use the information below, or use the information above to evaluate if there is strong evidence that the difference in husband and wife ages differs for different ages. That's an interesting one, because they're not saying whether or not there's a correlation between the ages of the husband and wife. They're asking whether or not it differs for different ages. So what they're actually doing is subtracting. No, they're not. They're comparing the ages between the husband and the wife. So if the husband's 20, the wife is like 18 to 22 kind of thing. So use the information above to evaluate if there is strong evidence that the difference in husband and wife ages differs for different ages. Okay. I think maybe what they are getting at there is this line here. It says if this were the case, then the slope parameter would be b1 equals 1. Now our slope parameter is 0.9112. So it's close to that, but it's not on that. And so I think that that's what they're asking you to comment on in part A, is to say that b1 is not equal to 1. And then you should explain that it's close, but that the fact that it's not equal to 1 could be explained by the fact that as people get older, it seems to, the data seems to spread out a little bit more, so there seems to be an increasing difference between the ages as people get older. For B, write the equation of the regression line. That one's an easy one now because we have what we need. So if we do y hat for this one, our slope is 0.9112, and our y-intercept is 1.574. I don't know if I can squeeze that in. You'll have to put it in yourself there. I ran out of space, okay? Interpret the slope and the intercept in context. So the slope is interesting because the slope is, we're looking at how much the wife's age changes as the man's age changes. And so it looks like, in context, that the woman's age goes down slightly as the man's age goes up. So it's still increasing, but it's increasing at a slower rate. It's not 1 to 1. So I think that's what they're looking for there. And the intercept, in context, the intercept is kind of weird because it's 1.57, and usually the intercept means when the dependent variable, which is the husband's age, is equal to 0. What is the independent variable? And so, first of all, you wouldn't have people getting married when they're 0. And second of all, it would match up with the wife being 1.574 years old and marrying a 0-year-old husband, which doesn't really make sense in the context of our problem. I think what it really tells us is that there's a slight, the women are slightly older than the men overall. So for D, it says r squared is 0.88. What's the correlation in ages? So just take the square root of r squared there, and that'll give you your correlation, which is r, okay? You meet a married man from Britain who's 55 years old. What would you predict his wife's age to be? You can just pop 55 right into the equation and end up with the estimate of his age. No, you can't. I'm sorry. They're saying the wife is 55. And, oh dear. Sorry, I thought I was erasing. And now I can't erase. So we'll just cross that out. They're saying the wife, which is the independent variable, is 55. And so you need to solve this equation for x. Okay, so just, I ran out of space again. You should have the 1.574 there. Just solve that equation for x to find out how old the man is. And then it says for f, you meet another married man who's 85 years old. Would it be wise to use the same linear model? And the answer to that is no, because if you read through the question, it says that they only surveyed men and women, married couples up to the age of 65. And so after that, you can't really extrapolate from this data and expect it to remain the same. And that's what they're trying to explain there. And if you look back in your text, there's a quote from one of those late show comedians about the dangers of extrapolation. So that's what they're getting at there, that you can't really assume that things will continue along that same pattern if they didn't actually measure those data for their graph. And so you want to say no there for F, okay? So that takes us through question 2. And question 1, there was a couple of things that I wanted to go over. I might just send you an email about those a little bit later on, okay?